Happy Friday, Mustangs. Hope the test went well for you on block day. I'll get those soon and start grading them, and hope to have those back to you by Monday, because next Friday is one of the drop deadlines. So some of you may need to know if things are going okay or if they're not going okay. And if we need to talk about that next week, then certainly come find me and we can discuss sort of what your options are if that's a concern for you. Start a new unit today, complex numbers, and then that'll lead into factoring, solving quadratics. This is another unit where you've seen most of this stuff before in Algebra 2. We'll go faster than Algebra 2, a little deeper than Algebra 2. And so if your understanding of Algebra 2 is strong, this will be easy. If your understanding from Algebra 2 is not so strong, then it may be a struggle for you. And that's okay. Struggle is good as long as you'll commit to the struggle and use it to get better, rather than just throwing up your hands and saying, I don't get it, this is too hard. Everybody reaches that stage in math where it doesn't come easy and you got to work for it. And for some of you, you may have reached that. Others of you, it may be this unit or the next unit, but it hits everybody at some point. And at that point, you have to decide that you're going to do what it takes to get there. So, having said that, let's go ahead and start looking at complex numbers, and we'll do some notes on that. And then the assignment is Worksheet 1 that you'll get in a moment. Let's start with some warm-ups, although I don't know that I'd call them warm-ups. We'll just say they're problems for you to try. So I'm going to list them, and then I'm going to hit pause. And when I pause it, you pause the video, and you see if you can do these. These should be familiar from Algebra 2. Again, start easy, work our way up a little bit here. Some simple, maybe, hopefully, square roots that involve simplifying. Number 1 is an easy one, just to kind of get your brain thinking back towards square roots. 2, 3, and 4, you might need to think about those. So you've probably already got number 1 settled in your brain. It's 5. I'd be caution you, it's not plus or minus 5, it's just 5. For number 2, and after I do number 2, I'll hit pause, and I'll want you to hit pause and try the next two. A couple ways to do this that people teach. Probably the easiest way is to factor it using perfect squares. So of course we have to know the perfect squares, like 2 squared is 4, 3 squared is 9, and so on. So we have to know those. Let's see, 6 squared, 7 squared, 8 squared, 9 squared. And so you got to know those so that you can recognize when they are factors. So 12 has a 4 in there, so we could rewrite that as 4 times 3, because the square root of 4 is 2, and 3 is still stuck in the house, so 2 square root of 3. Alright, so why don't you hit pause on the video and try the next two. Alright, I hope you tried them. If not, you're waiting for me to do them. That's fine, but learn better by you doing than by watching me do. 18 I can split into 9 and 2. Again, I choose 9 and 2 because 9 is one of our perfect squares, and I can take the square root of 9. So 3 square root of 2. Number 4 I can split into 25 and 2. It's my guard dog in the background. 5 square root of 2. Hopefully those are easy. That's Algebra 1 stuff. But you may not have done it in a while, and maybe a refresher was needed. Alright, Unit 2, Day 1, Complex Numbers. The dog doesn't like complex numbers either, I guess. 2 things we need to know, and then we'll use this the rest of the way. The square root of -1. Up until now, we just said that the square root of a negative number, you couldn't do it. It just doesn't work. But sometime long ago, long before any of us were born, that showed up as a problem, and mathematicians wanted to be able to keep solving the problems where that happened. And so they just decided that we're going to call that I. And I stands for imaginary. And even though it's imaginary and you think, well, then it never means anything, it's completely just like made up and the math teacher's doing crazy stuff. Even after they came up with this, much later they realized this has quite a few real world applications, especially in electrical engineering. If you go into electrical engineering, I's are going to be all over the place. If you've heard of capacitors and inductors from physics, it's used a lot in that math, probably more than we get to in high school. But it's not just imaginary out there, nobody uses it. It's real world, even though it's an imaginary number. If we square both sides, well, we'll get I squared on this side, and if we square the square root, they wipe each other out, and we get -1. So those are the two I statements that we kind of need to know. Kind of depends on the problem which one is more helpful, but those are the two statements about I that we'll need moving forward. 2 Roman numerals. Second one's longer than the first. First one is just simplifying, which is what we did in warm-ups, but the warm-ups didn't have any negatives in there, so we need to do a little bit of practice with simplifying with negative numbers. So the square root of -20. Well, we can kind of take the same approach we did earlier, and that is splitting it into pieces that we can handle. I know what the square root of -1 is, so I can rewrite this as with a -1 out front. Well, not out front, still under the house. And then 20 I could split into 4 times 5. And then the pieces, the square root of -1 is I, the square root of 4 is 2, the square root of 5 we're stuck with. And then this just looks a little bit funny. We never write it that way. It's not really wrong, it just doesn't look right. We'd rewrite that as 2I square root of 5. Now, as you get practice on these, I fully expect that a number of you are going to skip this step, and then some of you are going to get good at these. You're going to skip this step, and you're going to look at that and you're going to go, well, the I comes out and then it's 2 root 5, so there's my answer. That's okay. To me, this is simple enough where if you don't show anything between here and here, that's okay, if you can do it. Square root of -36. Again, rewrite it, or at least rethink it. If you don't want to write it, you've got to at least think about it this way. Split it up. Square root of -1 is I. Square root of 36 is nice. That's just 6. And again, I6 isn't wrong. It just looks funny. So 6I. One more of those. Square root -27. I guess I'll shortcut this one a little bit. I know that negative is going to come out front as an I. And then 27 is 9 and 3. So 3, and then the I, and then the square root of 3. So there's some shortcuts to be had in there as you become more familiar with these. If it's troubling you, if you're struggling with it, slow it down and show the steps. Right? The important part is not how fast you go, but that you get the right answer. All right, I told you Roman numeral 1 was shorter. Roman numeral 2. Some algebra with the I's, some add, subtract, multiply, divide, power stuff with I's. So first, adding and subtracting. This is pretty easy. This is look for like terms, and it follows all the same rules that adding with like terms follows. So this isn't really that big a deal. 6 plus 2I minus 3 minus 4I. You can probably guess why I picked that one to do, because that minus sign is going to mess some people up, just like it probably did on the test. Make sure the minus sign gets distributed to everybody. And then you're just looking for like terms. So you've worked this problem 1,000 times before with x's and y's. Now there's just i's in there. X minus 3 is 3. 2i plus 4i is 6i. And just by convention, we usually write the I part second. So it would not be wrong to say 6i plus 3, but you're never going to see that as a final answer on a multiple choice test or in a standardized testing situation. They'll always put the I part second. Example 2. Negative 3 plus square root of negative 12 minus 4 minus square root negative 75. Again with the minus sign just to make sure you're paying attention. But we've also got some extra work in here. We need to simplify square root of negative 12. Okay, I can go through the steps. Negative 1 times 4 times 3, so that would be 2i root 3. Then I'm going to, a lot going on over here. Let's see, that's going to be 25 times 3, so 5i root 3 minus 4. Negative times negative is positive. I did a lot of work right in there without showing a lot of steps. Negative 3 minus 4 is negative 7. And then I root 3 and I root 3, we can add those together. Those are like terms. Right? Usually we're looking for x's or y's, but here we're looking for I root 3's. So 2 of them plus 5 of them equals 7 of them. And the is I root 3. So it's still adding like terms. You're adding the coefficients of the I root 3's. Probably the biggest mistake people make on adding and subtracting is instead of adding and subtracting, they multiply them. And it's clear as day. It's a minus sign right there. But every year on this test, it's supposed to be an easy one. Someone is going to multiply those and do a beautiful job multiplying, but this problem did not ask you to multiply, it asked you to subtract. So just be careful and pay attention. And there's middle child. There it is, thank you. Multiply, divide. Let's do a couple of multiplies and then we'll do a divide, because divide is a little bit tricky. Maybe you'll remember from Algebra 2. Multiply, 3i times 2 plus 7i. We know how to do this. Let's distribute. So 3i times 2 plus 3i times 7i. So that would be 6i plus 21i squared. Okay, all that's old news. What's new news is this I squared, which earlier we said was negative 1. So multiply and divide, we're on the lookout for I squared because we will replace it with negative 1. So this becomes 6i plus 21 times negative 1, or 6i minus 21. And again, that's not wrong to write it that way. We just put the I stuff second usually. So negative 21 plus 6i. But the whole point of that one was when I squared shows up, replace it with negative 1, which has the effect of changing the sign of whoever's got the I squared. One minus 3i times 4 plus 2i. Again, the difference between a multiplication problem and a subtraction problem. Right? Subtraction has the minus. It seems so basic, but nobody's going to mess this up. This one's multiplication because they're just right next to each other. This looks like a FOIL problem. Maybe that's overkill with the letters. First, outside, inside, and last. Careful with the last. Negative 3 times 2 would be negative 6. I times I is I squared. I squared, our brain needs to be setting off alarm bells that something's going on there. So I've got 4 minus 10i. And then minus 6i squared. Well, the I squared is negative 1. So that's going to become plus 6. Because negative 6 times negative 1, makes a positive 6. 4 plus 6 is 10. 10 minus 10i. By the way, I'll say it because you'll figure it out if you haven't already. Your calculator will do the I work. You can type that stuff into the calculator and it will give you these answers. So for that reason, you won't have a calculator on the next test. But if you're doing your homework and you want to check, well, the answers will be posted. But the calculator can do I algebra. All right, let's do some division, because you don't really divide, which that may sound funny, a division problem where you don't divide. 4 plus 3i over 2i. Well, remember that I is the square root of negative 1, and we don't like square roots in the bottom. So for the same reason that we want to fix square roots in the bottom, we want to fix i's in the bottom, because it's a square root and we don't like square roots in the denominator. So the problem there is the I. So just like we do with square roots, right, little side note, if we had 3 over square root of 2, we'd multiply top and bottom by the square root of 2 to fix that. Well, we're going to multiply top and bottom by I, because that will fix the I in the bottom. Makes the top a little more complicated. 4i plus 3i squared. In the bottom we get 2i squared. And now we've got I squareds all over the place, which is negative 1, so let's be careful. So this becomes 4i minus 3. So I've already reverted to, or changed to, not really even writing out I squared equals negative 1. I just know that I squared changes the sign of whoever it's with, because I squared is negative 1. Same thing in the bottom. I can write out equals negative 1 and show the multiplication, or I can just say I squared is negative 1, so that becomes negative 2. And this answer's okay format-wise, but we usually like to split them up, and we like the real part to come first and the imaginary part to come second. So let's see if we can do this. So that would be negative 3 over negative 2 plus 4i over negative 2. No, still not done, but that put the real stuff first, the imaginary stuff second. So 3 halves minus 2i. So on a multiple choice test, that would be the most simplified answer. On a free response test, I would take this as an answer. That would be okay. But a multiple choice test, you need to be able to get to the answer choices that are there. One more, one more of the division kind. 6 plus 3i over 2 minus I. So this denominator is a little more complicated than the last denominator, and you might remember how we handled these when there were square roots like that in the bottom. We'd multiply by the conjugate. Well, we're going to do the same thing here. So change that middle sign to a plus and multiply top and bottom by 2 plus I. Now, we just gave ourselves 2 FOIL problems. So this is where, as always in here, your algebra skills have to be strong, because that's 4 little operations, and then adding and combining, and then there's 4 more and adding and combining, and then looking to reduce. So there's like 10 or 12 little baby steps in this one problem, and you've got to be able to do them all correctly. Let's see. So FOIL, I'm not going to write it out. I'm thinking it in my head though. First, outside, inside, last, 3i times I. I'm almost always going to show this, because if I try to do too much in my head, I'm going to mess it up. 3i squared. So that becomes a minus 3. Some people will write it right away. That's kind of dangerous if you're trying to do too many steps at once. 12 minus 3 is 9. 6i plus 6i is 12i. Now let's go back and clean up the denominator here. Same thing, FOIL. First, outside, inside, And last, minus I squared. A couple of things, O and I always cancel. You remember that? You might remember that from this problem. The O and the I always cancel when you multiply by a conjugate. A lot of times people won't even write those because they know ahead of time it's going to cancel. That's why you multiply by it, to make it cancel. So that goes away. Minus I squared would become plus 1 because I squared is negative 1, so it changes the sign. And then 4 plus 1 is 5. And that's an okay final answer, but a multiple choice test is going to go ahead and split those up. 9/5 plus 12/5 I. So again, that's kind of a free response answer versus a multiple choice answer. Either answer is okay, they're both correct, but on a multiple choice test, if you make it this far, hopefully you can look at your answer choices and figure out that this is the same as that. All right, last little subsection here, and that is powers of I. So this is kind of a unique, strange, neat, maybe, if you're a math nerd, property of I. So I to the first, that's just I, right? Anything to the first is itself. I squared, we already said, was negative 1. I cubed, well, I cubed would be I squared times I to get 3 of them. So I cubed is I squared times I, or negative 1 times I. That would be negative I. I to the fourth, well, there's a couple ways to get there, but probably the easiest way to think about I to the fourth is I squared squared. Right, that'd be I to the fourth. I squared is negative 1. If I square negative 1, I get a positive 1. I to the fifth. By the way, I hope you write these in the same order I'm writing them because we're going to see a pattern here. I to the fifth is I to the fourth times I to the first. Well, I to the fourth is 1. I to the first is just I. I to the sixth. Again, we're going to keep using I to the fourth since I to the fourth is 1. It makes things easy. I squared is negative 1, so negative 1. I to the seventh would be I to the fourth times I cubed. I to the fourth is 1. I cubed is negative I. And I to the eighth, if we squared I to the fourth, or I to the fourth times I to the fourth, we get 1. So look at what's happening. We're getting this repeated pattern here. And so at some point you don't have to think about it. You can just write them out. So I, negative 1, negative I, 1. And there's all sorts of tricks about patterns and fours and remainders, but we're not going to ask you anything huge. If we did, you could kind of just count up to it. So if I ask you what I to the 15th is, you could say, well, here's I to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I to the 15th is negative I because of the repeated power thing. Let's do a couple of problems with those so you know what kind of thing we're looking for here. 2I all cubed. Well, the cube goes to everything, so we got 2 cubed times I cubed. 2 cubed is 8. I cubed, well, you either haven't memorized that it's negative I. That's not real likely. I don't memorize that. I just know that I cubed is I squared times I. I squared is negative 1, so this becomes negative 8I. So there's this whole pattern you can memorize, but really all you still need to know is that I squared equals negative 1. If you can remember that, you can figure it all out. 1 over 3I cubed. Well, I in the denominator, that's that square root thing. Let's see, I cubed we just said was negative I. So I'm going to make this 1 over negative 3I. So that's a little bit better, but there's still an I in the bottom. So multiply top and bottom. Negative 3i squared. Again, I'm showing my work because there's lots of negatives in here. Some of you are going to try to cram this all into your brain, and if you can do it right, great, but there's a good chance that some of you are going to mess that up when you try to square I, change it to negative, then account for this negative and try to land at the right spot. It doesn't take long to show a little bit of work. I squared is negative 1, so that makes this a positive 3, and so we get I over 3. Again, some of you are going to try to at least jump from here to the end. If you can get there, fine. I suppose if you really wanted to tax your brain, you could try to jump from there to the end. That's a good place to mess up not showing your work. So as always, show enough steps so that you don't mess up the problem. Alright, today's assignment would be Unit 2 Worksheet 1. And the answers are posted in Schoology. And then we'll go over it on Monday. And hopefully I will be back on Monday. I sure hope so. If you care, I'm feeling fine. The family's feeling fine. We're just following the recommendations to stay away, so we help everyone. We don't spread our germs around. Try to keep everybody sick so that we can keep having school this year. All right, guys. Thanks for watching. Have a great weekend, and I really do look forward to seeing you on Monday.